I'm Joshua Bardwell, and you're going to learn something today. If you're an owner of an Eachine Wizard X220 and you don't have Betaflight 3.1 installed on your copter, I'm going to show you how to put Betaflight 3.1 on your copter, and I'm going to walk you through every step of my configuration that I put on my Wizard when I installed Betaflight 3.1 on it. Some people saw my flight video of the Eachine Wizard and said, well, mine doesn't fly like that. And I'd like to think that that's because I'm an especially good pilot. And maybe I am a good pilot, but I don't like to brag. But I think a lot of it is attributable to Betaflight 3.1. It's really an amazingly good flying piece of firmware. So in this video, I'll walk you through the config, and you of course can just copy the config if that's what you want to do. In fact, I'm going to copy paste the config down in the video description, and you could just paste it in and it would probably work just fine on your copter like it worked on mine. You should still double check your failsafe and all your basic stuff before you go to fly, obviously. Don't just copy paste it and then expect to fly and wonder why something went wrong. At the end of the video, I'm going to show you how to flash the copter to Betaflight 3.1, and that may seem a little bit backwards to you. Shouldn't I show that to you first? And the reason for that is that when I originally flashed the board, my recording got lost, and so I'm going to have to reflash it, but I don't want to lose my config. So let's go through the config first, do the flashing last, and then you'll be ready to go. So here I am in the Betaflight configurator, and I guess the thing I need to show you first is how to get the Betaflight configurator. I don't want to skip that step in the assumption that everybody knows it. You get the Betaflight configurator by going into Chrome, and if you just search in the Chrome App Store for Betaflight configurator, ta-da, here it is. You're going to want to install this app into your copy of Chrome, and you can launch it, and there you go. The other thing you'll need to do is you'll need to set up your drivers. Now, if you have used the Clean Flight configurator or the Betaflight configurator to contact your flight controller before, your drivers should be good to go. But if the drivers have give you any trouble at all, if you have trouble flashing, I've got a video on how to sort out your drivers. It can be a little bit annoying, but go ahead and check that video out if you have any issues. So here we are in the Ports tab, and the main thing you're going to do here is set up what type of receiver you've got and where the receiver is plugged in. The Wizard comes from the factory with a little servo lead dangling out the top of it, and that is set up for a PPM receiver. If you're using a PPM receiver, all you need to do is plug it into that and you're good to go. If you're going to use a serial receiver, like I'm using an S-Bus receiver or a Spectrum receiver would be another example of a serial receiver, then you're going to need to do something slightly different. What you have to do is you have to take that servo cable out of the plug on the front of the board and plug it into the very same plug on the back of the board. And that will make the wires line up right so that you can use a serial receiver on UART3. And you can see I've enabled Serial RX here on UART3. That's what you'll need to do. And I've also enabled Smart Port Telemetry on UART2. That requires a little bit of fancy soldering, or it requires that you have a certain plug that doesn't come with the Wizard. So let's just set that aside and assume you're not going to do that unless you're a little bit of a more advanced user, in which case you'll probably figure it out yourself. Here in the Configuration tab, one of the major things you absolutely must do is I've got the board align set to 270 degrees of yaw. And the reason for that is that the way that the board is installed to get the USB port facing the right direction, the board is not actually installed facing the direction that it thinks is forward. And if you don't set this correct, then when you raise the throttle and try to fly, the copter will flip out. Okay? So the way to verify that you've got this correct, well, number one, if you just copy my setting, you should be fine. But the way to verify that it's correct is to make sure that your accelerometer is turned on, and then to go to the Setup tab and move the copter. And what you should see is that when you move the copter, when you pitch forward and backward, when you roll left and right, the 3D model should move absolutely correctly as you move the copter. If you pitch the copter forward and back and the 3D model rolls left and right, don't try to fly the copter. It will flip out. The board align must be correct to make that happen. Here in the receiver section, I've chosen a serial-based receiver, and I've chosen S-Bus as my serial receiver provider. If you're using a PPM receiver, which is the way the factory comes set up, you'll have this set to PPM. And if you're using a Spectrum receiver, then you'll have this set to Spectrum, either 1024 or 2048, depending on whether you're doing DSMX or DSM2. Here in the system configuration section, I've chosen a 4 kilohertz update frequency for the gyro, and I believe that's as fast as this board can do. Some boards can go as fast as 8 kilohertz, and a few can even go as fast as 32 kilohertz. In general, you want to run the gyro as fast as you can. In this case, I believe that's 4 kilohertz. And I've got the PID loop here running at 2 kilohertz, and I'll tell you why I did that. The PID loop, you also want to run, well, I wouldn't say as fast as possible. I think there's a point of diminishing returns. But the main limitation on your PID loop speed is your CPU load. And if I change this PID loop to go faster, what we'll see is that the CPU load increases. Now, I haven't saved that. That hasn't taken. A CPU load of about less than maybe 50% for Betaflight 3.1 is fine. And we're only at 23%. So why don't we run it faster? And the reason for that is that I'm using One-Shot 125. Now, the reason I'm using One-Shot 125 is when I went to calibrate the motors, calibrate the ESCs rather, using multi-shot, and these ESCs that come with the Wizard do support multi-shot. When I went to calibrate them, they wouldn't calibrate. They acted like they were receiving an invalid throttle signal. And I don't like that. Multiple people have told me that they were unable to calibrate with multi-shot, but the copter flew just fine. Okay, but that's not for me. So especially because if I can't calibrate, then I don't know that my ESC endpoints are correct, and I don't like that. So I would rather fly on one shot and give up just a little bit of performance, and then fly on multi-shot and take a chance that something isn't right. And it turns out that one shot is not happy running faster than about 2 kilohertz. Well, it can go a little faster, but the Betaflight guys have drawn the line at 2 kilohertz. If you have one shot selected as your motor protocol, you cannot run the PID loop faster than 2 kilohertz, and that's why we're limited to 2 kilohertz. Now, you'll notice I turned off the accelerometer, and that's because I'm a badass racing pilot who doesn't need no stinking auto level modes. If you are a person who likes to use auto level modes, you'll want to leave the accelerometer on. You'll notice when I turn the accelerometer off and I save, the CPU load will drop from about 25%. Ooh, wow, that's a pretty significant drop. Wow, I'm really actually amazed at how much that dropped. I wonder if I changed something else by accident, down to 12%. Big drop in CPU load by turning the accelerometer off, and that's one reason why badass racing pilots turn it off. We're not using it anyway, so why take the CPU hit? Down here in other features, I've got telemetry turned on. That's because I wired up telemetry. If you didn't wire up telemetry, you don't need this. I've got black box turned on. This board has a small amount, I think it's 8 meg of black box memory on board. You may as well use it. Got black box turned on. And I've got air mode turned on. Now, air mode's a little bit controversial. I think air mode is just how the copter ought to work, and I always turn air mode on all the time on all of my copters. Some people have a lot of trouble landing in air mode. The copter kind of hits the ground and bounces, and especially beginners have trouble. If you don't like that and you want to turn air mode off, go right ahead. But be aware that with air mode off, if you drop the throttle all the way down to idle, you will not have any control of the copter. It'll just turn into a rock and tumble. Okay? So if you want to be able to drop the throttle all the way to idle and still maintain control, roll left, roll right, etc., you need air mode turned on. I think the copter flies much better with air mode turned on, and I think I would rather learn to land with air mode on than to fly with air mode off. Going back up to the top here, again, I've got One-Shot 125 as my motor protocol. If you're using One-Shot 125, I feel reasonably confident that you can copy these exact values with no problem. Here in the Failsafe tab, wait a minute, you may be saying, wait, I don't have a Failsafe tab. Yes, that's because you need to enable expert mode up here. And in fact, you can even, if you click the gears here, you can choose to permanently enable expert mode, and that's what I do. Expert mode hides some options that might get noobs in trouble if they were to play with them, but hey, you got me to shepherd you along the way. You'll be fine. Here in the Failsafe tab, the main change that I make, and I do make this change for all of my copters, is I set the throttle failsafe to hold. And what that means is that when the RF signal is lost, or if the receiver browns out or shuts down, if for any reason the flight controller stops getting valid throttle values from the receiver, it will hold the last throttle position for a little while. Now for all the other channels, I leave them at auto, and what that means is that they're going to center. And that means that if you're in auto level mode, the copter will go into a hover. If you're not in auto level mode, the copter will maintain its last orientation and continue doing whatever it was doing. The reason I choose to hold the throttle instead of going to auto, and by the way, auto throttle would chop the throttle immediately. The reason I choose to hold the throttle is I would like just a tiny bit of grace period for the copter to still be in the air if the RF signal briefly drops out and then comes back. And that grace period is set here, guard time for stage 2 activation, and I've got it set to 5, which equates to 1/2 second. So when my receiver loses radio link, for 1/2 second, the copter will maintain its last throttle position. And what that means is that if I was doing a big punch out, I'm going to keep doing a big punch out. And it means if I was, descending, I'm going to keep descending, whatever I was doing. And then after 1/2 second, if the radio hasn't come back, the copter will shut down. It will drop out of the air. And that is what you see this land right here? That's a lie. Forget that it exists. It should not be in there. It is distracting. It is a bad idea, in my opinion. Don't ever use it. Landing just puts the copter into auto level mode with a preset throttle position, but it has no way of knowing what its altitude actually is, or even if it's climbing or descending. And so it's just not a reliable way to, listen, this is a racing copter. It's a mini quad. If you lose radio link, into the ground. That's the safest thing to do. So I give myself that 1/2 second grace period, and then after that, drop, everything shuts down. That's how I set up failsafe. That's how I think is a good way to do it. PID tuning. Well, we're not going to talk about PID tuning here. And in fact, I haven't done any PID tuning on this copter. And I got to tell you, it flew great. It didn't fly perfect, but it flew really well. And I feel safe saying that for the vast majority of the kind of people who are going to buy a copter like this, probably this is one of your first copter, likely. You're not maybe the best pilot. You will do fine with these PIDs. These PIDs could be 5 or 10% better, but I don't think most of you are ever going to notice. And don't waste your time screwing around with PID tuning. Learn to fly before you learn to tune. Once you get to the point that you're a good pilot, then you can start thinking more about tuning and getting to be a better pilot. Now the rates that I've got here, they may be too much for especially new pilots, and you might want to reduce the RC rate down to something like, the default is 1.00. And you can see that at 1.00, we get a rate of 667 degrees per second, or more or less 2 turns, 2 flips per second. That's actually not a very fast rate, and especially if you're trying to do acro flying, you're not going to find that to be very satisfying. So you can find a value somewhere between 1.55 and 1.00. You can play with the RC rate. The super rate, I actually would just leave that alone and adjust the RC rate to get the stick as sensitive or as soft as you feel like you need it. Here in the receiver tab, there are a couple things that you absolutely must check. Number one, you have to check that your channel mapping is correct. Now what that means is that when you move the throttle, that's the left stick up and down, assuming you're a mode 2 flyer, which most of you are going to be. When you move the throttle channel moves. And when you move the yaw, that's the left stick left and right, the yaw channel moves, and so on for pitch and roll. And you can verify that using the 3D model over here. When I yaw left and right, the copter yaws. When I pitch, the copter pitches forward and back. And when I roll, the copter rolls left and right. And if any of that is not correct, you have to fix it before you fly, obviously. Now, if your channels all move correctly, but they're not mapped right, in other words, if you pitch but the copter rolls, that means your channel mapping is not correct. And you can fix that here using the channel map. So the channel map is saying that channel 1 is rudder, channel 2 is elevator, channel 3 is throttle, channel 4 is aileron. Now that's yaw, pitch, throttle, and roll. I understand that that's a little bit confusing. Why don't we use consistent terminology for all of them? Because, sorry about that. You can fix the channel mapping simply by reordering these letters. So for example, if your roll and your yaw are flipped, they're swapped with each other, you could change this from RETA to AETR, and that would fix it. If any of your channels are reversed, and what that means is that you pitch forward but the copter pitches backwards, you need to fix that in your transmitter. Somewhere in your transmitter, you'll have a channel inversion or reversing option. You're going to need to find that, and you're going to need to fix it. The other thing you must check is that your channel endpoints are correct. So you can see here that my channels are centered at 1500 microseconds, and that's where they should be. If any of your channels are not centered at 1500 microseconds, use sub-trims in your transmitter to fix that and make the channel center at 1500 microseconds. If your channel does not, take a look over here at the 3D model, if your channel does not center at 1500 microseconds, you will have some constant drift. Your copter will always be slightly trying to yaw to the left, and you'll need to fight that with your fingers, and you definitely don't want to do that to yourself. The other thing is that the channel endpoints must be 1000 at the bottom and 2000 at the top, and you use endpoints in your transmitter to fix that. If you cannot get your transmitter to reach 1000 and 2000, and with some transmitters it can be hard to do or impossible even, you can use the RX range command in the CLI to adjust the endpoints that CleanFlight expects to match what your instead of changing your transmitter to match what Betaflight expects, you adjust Betaflight to match what your transmitter can do. That's not a topic I'm going to cover, but it is out there. You can research it on your own if you feel like you need to. Okay, so our channel mapping is correct. The 3D model moves correctly when we move the sticks, and all of our channels go from 1000 to 2000, or 2000 to 1000, and 1500 in the center. You are now ready to move past this tab. Here in the Modes tab, I like to use switch arming, and what that means is that I flip a switch to arm the copter. I do not use a stick command. The old way that we used to arm the copter is to push the left stick down and to the right. I don't think that's good. I think it's better to use a switch. Even the cheapest transmitters these days have plenty of switches and plenty of channels spare to use switch arming. I think you should use switch arming. Now, I have got my modes set up here for arming, and I actually have a video I've got about how to set up modes. Instead of covering all that here, I'm going to just put a link to the video in the upper right, and you can go watch that video. But basically, I have one switch, and when I flip the switch, the copter arms. When I unflip the switch, it disarms. That's the way I like it. That's other people disagree. Some people say I don't like switch arming because if I accidentally flip the switch, I immediately disarm, and then the copter just falls out of the air. And there's one guy recently who accidentally dumped his copter in the ocean, dumped it in the salt water. Oh, what a heartbreak, because he accidentally hit the switch while he was flying. The flip side to me is that when I want to disarm the copter, darn it, I want to disarm it right now, because I can't tell you more times than I'd like to admit, the copter's been upside down, the motors are screaming, it's flying into a bush. I don't know. I just want to turn it off right freaking now. Or you're flying and you hit an air gate as you're racing, and the copter hits the air gate and wah, spins out of control and it's heading for the stands. You want to disarm it right now. Accidentally disarming in the air? Don't do that. All right. I don't know. That's my perspective. You may or may not share it. Anyway, if you're going to fly with air mode turned on, you absolutely do need switch arming. It's very, very hard to land with air mode on if you're not doing switch arming, if you're doing stick arming. Because while the copter is trying to land and it's going bang, 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 and bouncing off the ground, bouncing all over the place, you're trying to input the stick command down and to the left to actually disarm it. Switch arming's better if you're using air mode. Here in the Motors tab, there is something you're going to need to do. You're going to need to calibrate your ESCs. Now, the copter comes completely flyable from the factory, and in fact, you don't, strictly speaking, need to calibrate your ESCs if you don't want to, but it's not hard. You can do it. Basically, all you do is, heck, let's do it. Disconnect the battery. You tick this box. Thank you. You raise this slider all the way up to the top. You plug the battery in. You should hear that exact tone.
Telemetry recovered.
And then you put the slider down to the bottom like I did, and you should hear that exact tone. I didn't want to talk over the tone. If you do this, do it with your props off. I'm so seriously not kidding. If your props are on and you put this slider up to full and anything is not right, the copter will try to fly to the moon, except instead it will fly into your face or your computer or your ceiling. I'm not kidding. Do this with your props off. I'm not kidding. That's how you calibrate your ESCs. It's just that simple. The reason I suggest you calibrate your ESCs is that the default configuration from the factory, in my opinion, is not quite ideal. And I gave you a couple of different values back on the configuration tab that I think are better. But since you changed those values, you also then have to redo the calibration. And you just saw it. It took me like 5 seconds to do it, right? 10 seconds. There you go. There's one more thing to change. You'll notice probably that when you go to fly, there's like a dead space at the bottom of your throttle. Like you start to raise the throttle and nothing happens for like a little bit of travel. And that's kind of annoying. A lot of people don't like that. It's especially annoying when you're flying if you lower the throttle and you mean to kind of just lower the throttle almost to idle, but you cross through that threshold into the dead space at the bottom of the throttle, and now you're just basically at zero. The way to get rid of that dead space is to adjust a parameter called MinCheck. MinCheck, well, let's not go into a treatise of what MinCheck is. The key thing is that the throttle must go below MinCheck or the copter won't arm. Now the default value for MinCheck is 1100. And if you move your stick until you see 1100 on the throttle channel, you'll see that's quite a lot of movement, way more than you need. If you put your stick all the way down to the bottom and you got 1000, there you go. So what you can do is you can set MinCheck to a lower value, and that'll get rid of that deadband at the bottom. But MinCheck has to be at least as high as whatever your throttle goes down to. Now I have a half decent gimbal in my Tyrannus, and if you have a half decent gimbal or even a very good gimbal, when you lower the throttle, you may find that it always goes to 1000, in which case you can safely set MinCheck to maybe 1005. Just give yourself a little bit of space there, right? You wouldn't want to set it to 1001 because then, God forbid, you can't quite, maybe the stick doesn't quite go all the way down or some dirt gets in there and then it can't get below that value. What you want to do is you want to lower your throttle all the way down. Don't push on it too hard, just lower it gently to the bottom, and whatever value you see it hit, and it should be 1000, but if for some reason it isn't 1000, you can set MinCheck to just slightly higher than that. So here's how you do that. You go to the CLI and you type set min_check equals, and I'm going to use 10005. And then you're going to type save. And that's it.
Battery critical.
Again, that's not mandatory that you do that, but it is a nice thing to do. A lot of people are really annoyed by that deadband at the bottom and want to get rid of it, and that's how. And that brings us to the last part of this video, which is how to flash Betaflight 3.1 to the board. Now this is going to be potentially a little bit frustrating. It is frustrating for a lot of people because sometimes flashing a Betaflight board or a CleanFlight board just doesn't work right, especially on Windows. There's weirdness with the drivers and with the Chrome app, and I'm sorry in advance for any trouble this may cause you, but I'm going to show you what hopefully is the easiest way to do it. The first thing that you need to know is that the SP Racing F3 board that is in the Wizard absolutely has to manually be put into bootloader mode before you flash it. Bootloader mode is a mode where the board can accept new programming, like Betaflight 3.1. And some boards can automatically put themselves into bootloader mode when you try to flash them. You don't need to do anything explicit. You just go firmware flasher and you pick the one you want and you go and you just hit flash and away you go. I've never in my life had that be successful with an SP Racing F3. And in fact, if you try to flash the board without putting it in bootloader mode, not only does the flash fail, but the board just becomes non-functional. Don't worry, you can just fix it by flashing it correctly, but you're not going to go out and fly until you have to basically rebuild the whole config. So here's what you need to do. You need to get a paper clip, and you're going to unbend the paper clip into kind of a U shape. And on the board, there are some pads that are labeled boot. Here they are. They're right there. It's not in focus, but those are the bootloader pads. Look where they are on the board. It says boot right where my finger is, okay? You're going to take the paper clip and you're going to jam it in those two pads so that it bridges between them. There's two pads. They're called the bootloader pads. You're going to stick the paper clip in so that it is one end is in one of those pads and one end is in the other pad. And what that means is that when the board boots up, it will now be in bootloader mode and you can flash it. Now I want to show you what happens when I plug the board in and it's not in bootloader mode. In other words, it's just normal operation. I want you to watch what the LEDs do when I plug this board in. Do you see the red LED flashing here? And when I plug it in, I'll do it again. When I plug it in, watch how the blue LED comes on and then the red LED flashes rapidly a couple times. You see that? Okay, that means the board is in normal operation. Okay, that's not bootloader mode. Now when I've got it in bootloader mode with the little paperclip inserted, watch what happens. You see the red LED didn't flash and the blue LED is on solid. Okay, that means that it's in bootloader mode. That's what you need to see before you try to flash the board. If you don't see that, if the red LED flashes, that means don't try to flash the board, or you won't be able to fly anymore until you successfully flash it. You'll kind of put yourself behind the 8 ball. Okay? Solid blue LED, no red flashing LED. So now the board's in bootloader mode, and the next thing we're going to do is we're going to click Show Unstable Releases. If you are watching this video at some point in the future after Betaflight 3.1 has released, you won't need to do that. It'll just be in the pull down here. We're going to choose the SP Racing F3 board type, not the F3 Evo or the F3 Mini or the F3 Neo or any of that's just the F3. And then I'm going to choose Betaflight 3.1. Having done that, we'll click Load Firmware. And then we'll click Flash Firmware, and it probably won't work. Yeah, see, it didn't work. Okay, that's going to happen to you. Don't freak out. Let's try something different. That always happens. It never works the first time. If it works the first time, you're having a good day. So the next thing I'm going to do is I'm going to check No Reboot Sequence and Flash on Connect. And also Full Chip Erase. That's probably optional, but let's do it. Okay. So now I'm going to unplug the board. Paperclip's still plugged in. And as soon as I plug the board in, Betaflight's going to try and flash it just the minute it connects. Let's see if that works. No, it didn't work. Okay. Now don't do anything yet. Just try hitting Flash Firmware one more time. Nope, still didn't work. Okay. Well, there's one other thing to try. I've unplugged the board again, by the way. I'm going to try manual baud rate and see if that works. Some boards need manual baud rate, some don't. Let's see if manual baud rate makes it work. Plugging it in. And oh, it's working. Okay, that did it. What you've just watched is what I go through every time I try and flash Betaflight to a board that's being a little persnickety. Sometimes it works the first time, don't get me wrong. When it doesn't work, I just go through the permutations. Try it with Flash on Connect. If it doesn't work when I plug the board in, try hitting Flash Firmware one more time. If it doesn't work with manual baud rate, try it with no manual baud rate. Try it with manual. Eventually, I get it to work. Here we go. And done. The other thing to tell you is that very often the verifying step fails. Don't let that worry you. It's never been a problem for me. So if you get through flashing, but you get to verifying and verifying fails, don't sweat it. There we go. We flashed Betaflight 3.1 to the board. If you have trouble with any of this, chances are that your drivers are not installed correctly. You will know that your drivers are not installed correctly because up here where I have COM3, and you may have COM6 or COM7 or whatever, but if you don't see COM3 but you see manual selection, that means your drivers are not installed correctly. You got to go back and install the drivers. And I have a video on that. I'll link to it in the upper right. The final thing I'm going to show you is how to paste my configuration into your copter, if that's what you want to do. And the way you do it is you're going to go plug the board in, not in bootloader mode. Pull that paperclip out of there. You're going to connect to the board, and you're going to go into the CLI. You're then going to copy all of the text that I've got down in the video description, not the whole video description, just the configuration lines. You're going to copy that, and you're going to paste that into the CLI. And you hit enter. You'll see a bunch of stuff like that, and then you'll have my config. You should still double check that things work correctly, double check that the endpoints are correct in the receiver tab, that the channel mapping is correct, because your channel mapping may not be the same as mine because you don't have the same transmitter as me. Double check that your failsafe works. The way you double check failsafe is you arm the copter with the props off, and then you turn your transmitter off, and the motor should stop within about 5 seconds. About 3 to 5 seconds at absolute most. They should stop. If they don't stop, your failsafe isn't right. You can't fly. You got to fix that. Check everything, and then you'll be ready to fly. But hopefully this at least is a good starting point, even if you can't directly copy and paste it in. Oh, last thing you'll need to do, of course, is type save, and that'll save the config. Well, all right. I hope that was super educational. I hope you learned a lot about Betaflight options and configuration, and I hope you now can put Betaflight 3.1 on your Wizard X220 and get your configuration all restored and ready to go. And you should. It flies much better with Betaflight 3.1 than it does from the factory. It's very worth it. Thank you so much for watching. Hope you enjoyed it. Happy flying.